Good evening. Good evening, ma'am.
Uh, How are you? Long time no see.
Really good, ma'am. How are you? How did your function thing go?
Hi, amazing yaar. मजा आ गया. Yeah, it's very hot. Yeah, but yeah. I mean, I could complete so many things which definitely would have been impossible, with the classes, and I would have to delay it, and delay was never an option on our cards.
Good evening, ma'am.
Hello guys, good evening. कैसे हैं आप सब? How are you all? Doing well.
Good, ma'am.
I just wanted to confirm, did we start um, wave nature at all? No, right?
In the doubt class you started, I was asking that question on circumference. You gave us an idea of de Broglie's concept and that
I just gave you an idea.
circumference with wavelength that we did.
That's it, right? That's it. Okay, turn on your cameras, please, quickly.
Good morning, ma'am. Sorry, evening.
Good evening, good evening, good evening, guys. How are you? How are you? So I hope particle nature from Namaste is totally over, huh? Now to everybody should do this with a big nod, right? Turn on your cameras, guys. It's the same set of rules as before. Come on.
Good evening, ma'am.
Good evening, good evening.
Good evening, ma'am.
Good evening, Aditya, Rishma. Aradhya. Aradhya, you've been here since, I mean, you've missed a lot of classes in the past also, right? How are you?
Yes, ma'am, I missed a few classes because I
Why?
was completing my previous lectures and then examinations were going on at school, so I wasn't getting time.
Now, have you done all the backlogs, like completed all the backlogs and things?
Yes, ma'am, I have.
Ashriyash, you went off when I gave the test last class, last two, and I cannot actually see you. There's too much of light in your background. I actually cannot see anything. There's like a halo around you, like God.
Just a minute, ma'am. I'll fix it.
होता है ना भगवान के आसपास हेलो. भावेश इसी में कंफ्यूज. वो भगवान को ऐसे रिप्रेजेंट नहीं करते हेलो के साइन उनके उनके सिर के आसपास हेलो रहता है ऐसे ऐसे. भगवान जैसे लग रहा है वो. गॉड ऑफ फिजिक्स, गॉड ऑफ केमिस्ट्री. Now I can see you've seen the light, man. We all have. Aradhya, Pavneet, Abhijay, Isabel, turn on your cameras. And how is everybody doing? Pavneet, are you new? I have not seen you here before.
Yes, ma'am. Ma'am, today is my demo class.
Turn on your camera, then at least we should see you.
Yes, ma'am. I'm turning it on just a second.
Isabel, Aradhya.
Just a sec, I'm joining from a different device.
भावेश, तुम्हारे स्पेक्स किधर चले गए?
They are removed.
गुम गए?
No. Doctor said that now you can remove it.
सही में ऐसा कैसे हो? क्या खा रहे हो तुम ऐसा? मैं भी अपने बेटे को दूं?
Ma'am, I am having the minimum power of 0.25, no, that's why.
मुझे लगा कोई स्पेशल डाइट है यार, हम भी फॉलो करें, मतलब मेरा बेटा भी फॉलो करे. How many of you have finished the particle nature from NCERT? Raise your hands right now. Come on, quickly.
आप जाओ यार, आपने तो भगदड़ मचा दी.
I actually cannot hear you if you're saying something, Pavneet. Okay, from NCERT Exam Plus. Unraise your hands if you haven't. Okay. Anavasthi.
Ma'am, you mean all the
Yeah, Vijay, तुम्हारा हाथ नीचे क्यों चला गया भाई? Ashreyas, why? Not done?
ma'am, you mean up to level 3?
Himanshu? What about you? You're not doing? Why?
Mom, are you asking me?
Yeah, Himanshu is your name only and there is no other namesake.
Mom, it's half done.
Pavneet, where are you from?
I'm from Delhi.
Which school?
St. Thomas's Dwarka.
St. Thomas's is in Connaught Place, but that is for girls, right? But
Yes,
that's the
ma'am.
same branch is for co-ed now. It's co-ed in for Dwarka. It's the same thing. It's the same like
No, ma'am. No, it is not the same.
it's a different management, right?
Yes, ma'am.
I thought it's the same St. Thomas's. In Mandir Marg mein hai na? St. Thomas is very famous for
Yes,
girls.
ma'am.
I thought wahi hai.
No.
Okay, ji. All right. So we have done NMS. A lot of people have done NMST and some people are yet to finish NMST. I would strongly recommend you all to finish it. Jitesh, what is your update on NMST? Please tell me.
I didn't complete it fully, mom. There are a few more questions.
You need to speak into the microphone. I cannot hear you.
There are a few more questions more, mom, after complete. Hello.
There is some problem with it. I cannot hear. Nice idea. Now I think it'll be better. So we have done the advantages. If you guys have not done some, portion of NMST and you still need to do it, I would strongly tell you to personally DM me the reason. Okay. All right. Okay, I've got yours. If anybody else hasn't, then please let me know. Okay. Now, all through, the discussing the particle nature of light, we have studied that light is in packets of energy, and these packets are having the energy depicted by this formula, correct? N is the number of photons which are associated with this energy, correct? All right. Also, there will be some questions in NMST which you will not be able to do. Okay, it is okay. It's fine. It will take some time for you to get a knack of it. And I would suggest complete the whole chapter and then only do it. Yuvraj, I didn't want to type it in chat because it was very long. And I thought I would explain it in the class only. ठीक है बेटा? एक ही बार में सब कुछ नहीं आएगा. You have to understand that, right? It will be gradual. Okay. I'll give you a question today also. And then maybe, you can try that. And sometimes when you've done more concepts of maths as well as related to chemistry, you will be able to do many things.
Okay, bache? Right? Please pick up a book of PYQs. Have you purchased any, by the way? All of you. If you haven't purchased, try purchasing it within the next 15 days because I think the new questions would have been included. Purchase right now only for mains. Okay. If you're able to do chapter wise PYQs of chapter number 1 and chapter number 2, okay, till particle nature, you are good to go. All right, beta? All right. Fine.
Ma'am, will the
And-
PYQs given at the end of the module do?
Yeah, module at the end of the modules, I think they have given, but only a
The
few.
PYQ.
Also, what you can do is you can pick up the last 4-year questions from the net. And then, there are solved papers from the net, right? You can
Yes.
solve the questions of whatever you can of chapter 1 and chapter 2.
Okay.
If you don't want to purchase PYQs right now, because some of them may get updated, some of the good publication houses, they do take time in, updating the whole thing with the 2025 question papers. And they will be definitely out till August. August is the last time that the PYQs get updated in any PYQ book, because then, in January, there's the next paper. So the students need to practice also.
Okay.
July end, maximum August, you can purchase. But if you have like the access to some, and if you can get it off the net, then it's very good. The modules are definitely filled with PYQs, definitely. Any practice book
Yes.
that you're also having does have PYQs, the latest edition one, right? So it's not a big problem and you can get it off the net also. That is not a problem, but do try to practice, right? And right now, I would tell you, wait till at least October, September end before you try JEE advanced problems, right? I will be giving you JEE advanced problems, but there are some tougher ones, right? Which we will give you in class 11th full syllabus paper. When you get the details of the first 5 to 7 chapters, then you will be in a better position to do them. Okay, beta? Then you will be in a better position to do them. Abhi, if you can do the mains problems very well, then yes, you're in a good position. Okay. I'm not saying don't do advanced. If you can do advanced, if you can get them, it is well and good. But Abhi, if you expect you just did particle nature and Abhi only you will be able to solve all the problems, then you need to study more, you need to read more, you need to practice more. That's what. Okay, Yuvraj beta? I really so wanted to answer that question of yours at that point in time, but I thought, okay, let me just say it in front of everyone because everybody would be practicing and everybody needs that kind of information, right? To go ahead. Okay. So, wave nature. I have already told you that De Broglie was the student of Sir Niels Bohr, right? And he was, as the experiments were being conducted, he kept on, leaning towards the wave nature. And he subjected his own internship students. They were the very famous Davison and Germer. And he told, why don't you run the electron from the diffraction experiment? And it is a very famous slit experiment, which you will be doing in physics also. And the electron very well gave that test, right? It very well passed through the diffraction pattern. It gave a particular diffraction pattern. So De Broglie definitely, he did, tell them to verify this, but himself, he gave a hypothesis. And I remember telling you a hypothesis, and we discussed in the previous classes that a hypothesis is different from a theory in the sense that a hypothesis is like when a scientist has he or she has read different theories, right? They are proposing a certain point. They have not done experiments to prove it. Whereas when you read Bohr, so what did you do? So you wrote Bohr's postulates. You remember that? You did Bohr's postulates. Postulates belong to a theory. They're a direct result of what the scientist has performed in an experiment conducted by themselves. But a hypothesis is really something which, various points that they have gained insightfully from other people's experiments. What you derive, what you express from various experiments, that is hypothesis. So every particle nature possesses wave and particle nature. Possesses wave and particle nature. Possesses wave and particle nature. Okay. Now, he particularly said that if every particle is associated with wave nature. Now by particle, I mean, heavier particles also, lighter particles also. Then the wavelength of that wave is given by h upon mv. Okay, then the wavelength associated with that material is known as, given by the formula h upon mv. H is 6.626 into 10 raised to power minus 34, which is Planck's constant. Yes, Joule second. This is Planck's constant. mv is momentum. Yes, linear momentum. Momentum is the amount of motion contained in a body. Yes. Did we prove it for an electron and a ball?
Yes, ma'am.
Yes. So when we calculated the lambda for an electron, it came around, the value of an angstrom, right? It came x into 10 raised to power minus 10 meters. And lambda for a cricket ball, which was of 500 grams, it came at around, x into 10 raised to power minus 39 meters, if I'm not wrong. Correct? Around that. So I told you that this becomes immeasurable. This is measurable. Right? So from de Broglie's hypothesis, one can easily understand that his hypothesis was meant for only subatomic particles, atomic and subatomic particles. So you can write down from the hypothesis, one can easily figure out that this hypothesis is applicable for atomic and subatomic particles. Today we will do Heisenberg's uncertainty principle, and Yuvraj, I will take a question similar to what you had given, and we will and I'll tell you how do you think about those questions in the manner we should. ठीक है बेटा? I got such a question for you today. आज लेके आई हूँ. मैं आज इसका doubt solve करते हैं, बेचारा परेशान हो रहा है, right?
Okay, ma'am.
ठीक है, अभी तो समझ आ रहा है, अभी तक तो समझ आ रहा है.
Yes, ma'am, समझ आ रहा है.
युवराज है, गौरांगी है, अरिंजया है, सृजनी है, they and Bhavesh especially, if he doesn't understand concept, they will make it. You cannot understand. So then it scares me off, huh? What to do? Aditya will ask. Abhijay will also make a face like this. Abhijay, you are understanding right now? All right. All right. So now you have this, and we already have this from Bohr's second postulate, where he says that the angular momentum is quantized in nature. Yes. Right. And I told you how to express R for the nth orbit. What was it, beta Isabel? Please tell me. What was the relationship, bache?
N square by Z into 52
N lambda by 2 pi.
Oh yeah.
We derived this, right? Last time.
Yes.
This is almost, I think, question number 34 at the back of NCERT also. They are telling you to do the same thing. Okay. This is the first set of relationship that you need to know. The second is, can you express the momentum part in this particular equation in terms of kinetic energy, which is half mv squared? Come on. All of you. Start. चलिए बेटा.
নিয়ে যান
ঠিক আছে সৃজনী, ঠিক আছে।
ও সরি ম্যাম
কিছু হবে না, nobody understood. Even I didn't. You were
No,
speaking
ma'am,
in a
my
very
mother wanted something from the room. She said, I'll come.
no problem, no problem. I could hear that key. Srijani doesn't want to get disturbed, right, during the class. Let me do advanced level problems, mama.
Ma'am, I've got the equation in terms
Acha.
of.
Yes, ma'am.
ठीक है. Pavneet, it is correct. Yes.
Yes, ma'am, I done. Got the question.
Okay. Srijani, yes, please tell me.
Ma'am, I did mv square is equal to 2 into kinetic energy. So m square v square is 2m kinetic energy. So the lambda will be h by root over 2m k ek.
2m ek. Yes, perfect. Yes, everybody got it. Now one can understand that lambda is inversely proportional to the kinetic energy. Am I correct? Yes.
Yes.
Shall we do a question on it? Keep a track of whatever we are doing, whatever equations we are, deriving from this, because I will give you a advanced level question today itself, right? If, write down the question, please, everyone, quickly. If the kinetic energy of an electron increases by 44%, kinetic energy of an electron increases by 44%. Find the percent change. You have to find the percent change in its de Broglie wavelength. Start. Nobody will shout out the answer, please. You just have to raise your hands, beta. Okay, beta? Aditya, can I have the answer from you this time?
No, actually, I was coming to a different one. Could you, what is that symbol? The question.
Increases.
Yeah, what increases?
Kinetic energy. We just found it
Okay.
out, right?
Yes.
Joyneel, Sariska, and Devanandanan, please turn on your cameras if the camera is working properly. Pavneet, just check your answer beta once. You performed some calculation wrong. कुछ तो गलत किया है. Yes, Aditya, I told you to tell me the answer, बच्चे. हो गया बाबा? क्या आंसर निकला है? Baba
Yeah.
is confused. Why is Baba
Yeah.
getting confused? What is this? Bhavesh, excellent. Good. Good, good. Very good, beta. This is a JEE mains question. Good, beta. Badhiya. Bhavesh, what about the particle nature wala worksheets? You've done them all.
Yes, ma'am.
So answers, you didn't ask me for the answers only.
Ma'am, I got from the Google.
You could have asked from the answers. What is this wasting time on Google? Who else has got the answer?
Ma'am, I've got it.
Arey Baba re, no. Okay. Shall we go ahead into this? What is the answer? Srijani, you tell me.
Ma'am, getting 16.67%.
Perfect, perfect. Huh? Because it's a recurring decimal, right? How many of you are getting 16.67? Raise your hands right now. Good. Good. Very good. Arinjaya, quickly, beta, finish it up. Pavneet, what were you doing wrong? Aya, beta, kuch samajh? Gaurangi, beta. Yes, beta, yes, tell me.
Now I added the increase in percentage from the old one and then
You should have subtracted it. That's how you find percentage, na? So decrease. So basically, guys, what you're supposed to do is you're supposed to find out the initial wavelength because kinetic energy is inversely proportional to wavelength. So initial wavelength is more, na beta? Or it is less? Who is telling me?
Initial wavelength would be more.
This is how you find percentage. You all got your 10th class results right now. How did you get your percentage? Bhai, like this only. Right or not? Yes. From 100 marks, you subtract somebody got 100. Yeah, it's okay. So you got 10%. Somebody 1 mark less. So subtract 99. 99 by 100, huh? That's what you did. So mistakes are your kinetic energy in doing the
And-
questions. Yes. Who is having a problem now? Sariska beta. Sariska, you also missed a lot of classes. Where were you?
Ma'am, this is school timing was the problem, but I have seen all the recorded lectures.
Jitesh, now you're able to do now. Aditya,
Yeah, yes, ma'am.
Himanshu, Konika just joined, I guess. Pavneet, are you able to get it? Gaurangi,
Ma'am,
Aradhya beta.
calculation galat tha. I'll do it again.
Do it and get the correct answer right now. Otherwise, this will just, copy will be closed at 7 p.m. Then Gaurangi will tell later the notebook, or I forgot to do this. Aradhya beta, got it, bache?
Yes, ma'am.
Good. Please complete any pending lectures from the recorded videos. And I am strongly of the point of view, still, if you ask me, there is nothing like live lectures. You understand better, you can ask your doubts, right? Just try to avoid watching recorded lectures as much as you can until unless there's an emergency. An emergency is not going to the mall, please. Somebody told me, ma'am, I had to go to the mall to get my dress. What is this? This is not an emergency. You can avoid it, right? Right, Isabel? Isabel agrees. Any doubts? All right. Today we're going to watch a good video on Heisenberg's uncertainty principle also. Heisenberg's uncertainty principle was a stamp on the hypothesis given by De Broglie, right? But before moving on to Heisenberg's, I would like you all to open up your NCRTs, mark those 2 questions on De Broglie. Please consider them, you have to do them, homework or whatever you would like to call it, right? Do a few more questions, right? Actually,
Which 2 questions?
Vito, there are 2 questions in NCRT, solved questions that belong to NCRT, but you're supposed to open that. Solved questions inside the text.
Yes, ma'am.
Okay.
I'm in the same topic, no?
Ji beta. Yes. This is very easy. Quickly finish it off. Question, another question. Yes, please. Let's just write the next question. Have you marked those 2 questions for homework, bache?
Yes.
Right?
Can you repeat the question?
Beta, there are 2 questions. If anybody could just, Srijani, can you just tell me the numbers of the in-text questions, please? 2 point, I think, 12 and 13.
2.12 and 2.13.
Exactly.
Wavelength of a ball and mass of an electron.
I was just
Helpful.
thinking that it is 10, 11 or 12, 13. 12, 13. This is lambda 1 angstrom, okay? Please note the question down correctly. I'll just increase the. It then gets retarded through 19 volts. 19 volts. And then has a wavelength of lambda 2 angstrom. Okay. So first it is at rest, right? Okay. Then it is accelerated through a potential difference of 100 volts, having a de Broglie wavelength of lambda 1 angstrom. It then gets retarded by 19 volts and has a wavelength of lambda 2 angstrom. A further retardation through 32 volts. A further retardation (32 volts) changes the wavelength to lambda 3 angstrom. What you are supposed to find is find this. Okay. Take your time, do these 3 questions for homework. I'm sure you'll be able to get through the NCERT ones, right? This you have to think a bit and then you do. Okay. I would expect you all to have done that by Saturday. And by Saturday, I would want the doubts to come from the structure of atom, right? In the doubt class, right? We are going to have doubts of structure of atom, and Isabel's doubts I would like to discuss in class. Okay. If there are more doubts, because she posted them a while ago, right? If there are more doubts, please DM them to me. We'll be taking them up in class. Okay. Grishma, where are you? Long time. Where is this girl? I can't see her.
Ma'am, I'm in India right now, so my network is very.
Acha, you're in India. Okay.
I traveled like a few days back, so I'm trying to hear you, but then it's breaking too much, so I can't hear you.
You joined
properly.
late also, right? You didn't join on time, if I am correct.
No, ma'am, I did join on time. I'm rejoining like 3 or this is my 4th time rejoining the.
Oh, koi baat nahi. It's okay. No problem. Okay, so you all have taken down this question, bacho. This question. So I expect all of you to, do at least this question. What is the answer of the first question that I gave? This one, beta, the second one, practically. What is the answer of this, bacha? Rn is equal to n lambda divided by 2 pi,
2 pi.
right?
Yes,
So
ma'am.
Yes.
Rn will be what? R1 is equal to lambda upon 2 pi. So this is the minimum
Yes.
wavelength 2 pi R1, which is literally the circumference, right? Correct, no? Is this correct?
No, you asked minimum radius, so we will keep it till lambda by 2.
Yeah. Yes. I just took it to, wavelength because this question also has been asked. Right? What is the minimum wavelength? This question
Okay.
also has been asked. So just wanted to get through another point, right? Okay, bache. Got it. Not a problem. Things are clear. Yes, bache. This question has been noted by all of you. Good. Now getting on to Heisenberg's uncertainty principle. Just a little hint in the question above where electron volt is given. Electron volt is what? It's a form of energy, right? So retardation can be associated with that, just that. Okay? ठीक है बेटा? the retardation or the acceleration can be associated with the electron volt of energy, right? And then you have already related kinetic energy with lambda. है ना बेटा? That you can do. ठीक है? So can you see we did de Broglie's hypothesis and now we are doing Heisenberg's uncertainty principle. There is a difference. A principle is an outcome of the experimental analysis performed by a scientist. Hypothesis is just various, lines of theories that they might have got from other people's understanding and their own understanding of the thing. So there's a difference between principle, postulate, and hypothesis, right? Okay. So what does this principle say? This was an official stamp on the hypothesis of de Broglie. It says it is impossible to simultaneously ascertain the position and momentum
And what do you have written after simultaneously?
ascertain, find out correctly. Ascertain is to find out correctly. I mean, with full certainty, right? Ascertain is to find out with full certainty correctly the position and momentum of an electron. For that matter, this conversation can be extended to subatomic particles. Simultaneously, that means at the same time, right? So we cannot determine the position and momentum of a particle, subatomic particle like an electron correctly and simultaneously. That means if we were to catch hold of one, we would lose the certainty on the other one, right? That is nothing but calling something a wave, isn't it? Wave is a continuous flow, right? If you find out the correct position of one, you would have to let go of the velocity. Now imagine electron of mass 9.1 into 10 raised to power minus 31 kilograms, traveling with the velocity calculated from the Bohr model as 10 raised to power, for the first electron in the first orbit to be meter per second. This is what we did. Imagine an electron of this mass, a particle of this mass traveling with this speed. Can you ascertain the position? No way. If you ever were to do that, let's say, if you ever were to do that, would you be able to find out the velocity correctly? No. So there are techniques, but nothing can do it like perfectly. For full certainty, it is impossible. Joynil, please, you're asking a question. You want to ask something? Your hand is raised. Yes, please.
If you can ascertain the position of a particle, then can't you use recorded positions to determine average
You said
velocity
a
over
particle.
time?
Now I'm saying it's a form of wave.
Right.
Right. You just said particle. So
So what
I'm
if
saying
that wave gives out light? Then you can use the energy of the
if
light
you
as well.
use recorded position, then that recorded position would not be the correct position at that particular time, right? Where you are
Matlab?
measuring the velocity. Supposingly, you are recording the position in a certain time frame. Okay. Now in another time frame, it has changed its velocity, let's say.
Okay.
Right? So that's what I'm saying. With full certainty, you cannot, find out both. I'll show you an excellent video on this today. Okay.
Okay.
It is using a laser light, but you can actually, appreciate particle nature using that, watching that particular experiment that man is conducting. And you can also appreciate the wave nature, right? It's a good video. Okay, now how do you actually prove it? So in order to prove that we have a relationship, this is nothing but the momentum. It is actually inequality like this. In maths, we do inequalities, right? But for obviously for calculation purposes, we have to just, we'll turn it into this 4 pi into m. Why? Because I put m here because m is a constant. So I'm, the two things which are required to be measured versus, they are equal to a particular constant number, constant figure, right? Let's say if I just told you this condition that, the uncertainty in finding out. Now, what is delta x? Delta x tells you the uncertainty in finding out the position. Okay. Delta V is uncertainty in. Uncertainty means we are not sure where a particular position is, or we are not sure how much is the velocity of the particular particle in finding the velocity. Let's say in a particular time frame, we know the exact position. So delta x is 0, right? There is no uncertainty, na? There is no uncertainty. So delta x is 0. So delta V will be what? H upon 4 pi m into 0. This is what?
Infinity.
The uncertainty in finding out velocity will be infinite. Okay, right? If in any case, the other one is obvious. If in any case we know the velocity, the uncertainty in velocity becomes 0. We know the exact velocity, the uncertainty will become 0. So delta x will be what, beta? Position will become uncertain. The uncertainty in finding the position will be infinite. That means you don't know anything with certainty, right? You choose one, you lose the other. That is nothing but a wave nature. That is proving the wave nature of light, right? Whereas, if you remember the first and the second postulate of Bohr's model, what did he say in the first one? We know exactly the kinetic energy, the position, the velocity, everything I know of the electron. And I just told you. You can see it in daily lives. You just, we just saw what happened in IPL, right? So big, fast bowlers are going like this, that. So this goes on, this happens. What is this? Third umpire. What does he do? He slows the thing down and then he says whether the player is out or not. Why do you have to slow it down? Because the umpire who's standing right there, on the field cannot judge, right? Because the ball is very fast. That ball is 500 grams. 500 grams. This is 9.1 into 10 raised to power minus 31 kilograms. Like after 31 zeros, there is a 9. Imagine. Can I catch hold of the position? Even if I use very sophisticated instruments, I am not using human eye. You can argue that on that one. I'm not using human eye. I'm using very sophisticated instruments. Even then it is difficult. Even then it is difficult, right? So there would be some amount of uncertainty which does creep out at any given point in time. It will, right? So as we progress in this model, right, in this wave model, you will slowly appreciate how much flexibility is this model trying to give you as far as the structure of atom is concerned. Because till now, what you have studied is, you have studied that, orbits are fixed, position is fixed. This electron is rotating in this orbit, revolving around this orbit. This will get excited to higher level, come down to lower level, and this much amount of lines will be given up. Some amount of information is definitely true. Obviously, they have proven it. We can see the lines, right? We can see those lines emitted out in various, Lyman, Balmer, Bastian, all those series. We have done some amount of information is definitely correct, but most other information obviously needs correction. That correction comes out from when you tweak a particular theory, right? When a theory is, my PhD boss always used to tell me, Swandip, science belongs to those people who leave the door open. Like you discovered something and you leave it open. Other people can come in and correct. If you close the door and if you bolt it, then nobody will be able to enter into your theory. Nobody will be able to correct it. You might win the Nobel Prize, but there will be some other scientist some other day who will prove it wrong or might want to correct it. Right? So that is what we learn from Schrodinger. That is what we learned from his theory. Just give me 1 second. I will just show you that particular. Yes. Here it is. Now, listen correctly. I'm sharing the sound of what this guy has to say, right? First few minutes, I think you already know. Don't tell anybody. In chemistry.
Results. Pi. Now this h is just a small constant called Planck's constant. We can only absolutely know results. So now we know the theory behind it. Let's set up an actual experiment to see if we can see the same result. So the particles that I'm going to be using in this experiment are light particles, or photons. Now remember, photons don't have a specific mass, but they do have a momentum. And so the Heisenberg uncertainty principle still applies to them just fine. The way I'm going to be measuring the position of the photons is by sending it through these two razor blades. And I can get these razor blades closer together or further apart. So what I know is that any light that makes it through these two razor blades had to have gone through in this area. So that means that my delta x is related to the gap between these two razor blades.
Can you see now what he is talking about as delta x? Listen very carefully what he's saying, okay?
So I can decrease my delta x by closing it, or I can increase it by opening it like this. And then how I'm going to measure the momentum in the x direction is to see the spread of light. So if all of our particles come through and they hit the same spot right here, then that means they don't have a lot of variability in their momentum. But if one particle hits here, and then one hits here, and then one hits here, and one hits over here, then that means that in the x direction there's a lot of variability in its momentum. So what I mean by that is when we shine our laser light through, we can look at the spread on some backstop. And if the spread is large, that means there's a large variability in momentum. But if the spread is small, that means there's a small variability in momentum. So the gap that it goes through represents the variability in position. I'm measuring its position at this point exactly. And some distance down the way, I'm going to measure on a backstop its spread. And that's going to tell me about the x component of its momentum when it went through this position right here. So I'm going to start off shining it with a really wide gap right here. So our variability in x is really big.
Joy Neil, you need to listen. Watch.
You can see we come down here, go to the other end, and we see the spread of the light is pretty small. So it's just a tiny little laser light, just like you'd predict on the other end. And let's measure the width on this backstop here. Okay, so that's about how wide my beam is. Okay, now we're going to...
Can you appreciate how wide his beam is now? Now you see when he's going to just close this thing, right? And how the beam is going to turn out.
Close our gap more. Now I significantly decreased the variability in the x direction because they're so close together now. And you can see on the back of it here that it's actually blocking some of the light. So less light is going to be hitting at the end there, but let's go measure how big that dot is now. So this is a little bit odd. We can see our two markers here for the original beam, but now we have this long spread of light off the edges here. So turn the lights off. It's hard to say where this actually ends.
Can you see how hard it is to tell where the exact, the light, that beam, which is spread, has ended? Can you see it, bache? Yes? Can you all appreciate it?
Yes.
But I'm just going to try to make a guess here. Looks like it dims out about right here. And it dims out about right here. So look how big our variability in momentum is now. So the width of the beam actually got wider when we narrowed that beam. Now let's watch it continuously as I close the razor blades. You can see the light starts out bunched together, but as I close the razor blades, the light spreads out more and more and more until it even gets wider than my markers that I put on there
Can you see, beta? Can you see how things are changing as he is increasing and decreasing the distance between the two blades?
before. But then as I open up the razor blades again, the light gets bunched back together. So as counterintuitive as it seems, the harder you try to squish light into a smaller area, the more it spreads out. Now I already know what you're thinking. You're thinking this isn't some weird thing with the Heisenberg uncertainty principle, but it's actually just the diffraction of light, because light is a wave, and so when you send it through something small, it diffracts and spreads
This is the slit experiment that I was talking to you about initially, okay?
out. But if you're thinking that, the joke's on you, because this background is actually a glow-in-the-dark background. Now this red laser light has a very high intensity, so high that it should be able to charge this backstop, but it's not charging it. That's because light isn't only made of waves. If it were made of waves, it should be able to charge the backstop,
Joynil, did you get your answer? Now listen to what he says next.
but it's not. It's simply because the particles of red light coming through don't have enough energy per particle. If I get a little bit of light of something that has more energy per particle, then it can charge this backstop. But if I just get a non-laser light, blue ultraviolet light, you can see I can easily charge it. And so the particle nature of light is one of the reasons why this backstop glows. And so you can't say that light is just waves, because we're also seeing its particle nature right now. So they have to have been particle-like when they left the laser. Now, interestingly enough,
Yes. Could you appreciate it now? Could you all appreciate what he was trying to say? Not only did he prove the Heisenberg's uncertainty principle, he also told you how light is behaving like both particles as well as wave, right? So this video actually tells you about, yes,
Could
Sanju
you
beta.
please tell the last part once, that part, like how is it proving the particle nature? It's not getting
Wait.
charged, that part I didn't.
See, it's not getting charged, but he says it's getting heated up. I'll tell you once again. I'll just see what he says.
Ma'am, can I explain it?
Hanji beta, what are you saying?
Like, can I answer the question? that
Please,
she-
please. I would really appreciate that.
Basically, imagine this. You have your night lamp on your table, and your table's made of particles. But let's assume that light wave was as my bad.
On your table. Checked out.
My bad.
Turn off
So-
the Alexa. She is going to
Not
teach you
Alexa,
otherwise.
it's Siri.
Oh,
So-
Jodi भी Siri. One of my students is
let's-
also called Siri. Her name is Siri.
So let's assume that light is actually continuous. That means that every second, every fraction of time that light hits the table, it's giving constant energy to the particles. So in that theory, because light is continuous, the particles should gain enough energy to completely disintegrate over time. But the table does not disintegrate, it stays together. That means that light is not continuous, it must be discontinuous, and in those gaps where it's discontinuous, it lets that energy escape. That's basically what they're saying. So that's the
Did you
whole
understand or
photon
did you
theory.
get more confused? Srijan, did you get more confused? So it says what he is trying to say. I'll explain in like a simpler version. So what he says that when the light actually leaves the laser, up until it goes into the laser, it hits that, laser blades, that razor blades, right? So what happens is that, that it's leaving off as it, but when it touches that particular background, because intensity is not that much, so it is not able to charge it, but it is getting heated up, right? Why would it get heated up if it was not a particle? So it has to be
Like
like
that
both
particle
wave
is getting collected and it's getting heated up. The examples that you gave in the.
Yes, exactly. That is what Joynil was exactly saying.
Okay.
Siri interrupted him. He was, I really like it. The person who asked the question is answering. I love this.
No, ma'am, it's because I studied about this, so that's why.
Yeah, you studied, but you had a doubt now. Before
No,
this.
I just didn't study Heisenberg's principle, that's why.
But you got it now. All the doubts are cleared.
The UV light is able to show on that screen because it's more intense. So it's
Yes, of course. UV comes, now your question is even better answered because UV has why, Srijani? UV is way before in the energy.
Higher frequency, higher energy.
Yes, absolutely. Now you got it. Na? Red is way downward, in the visible region. It's the last color in the visible region. So less energy, UV has higher energy. Now things are clear, you guys. I hope that video really helped. Yes. Okay.
Yes,
Very
ma'am.
good. That's wonderful. So two more questions are there for Heisenberg's uncertainty principle, and that one question is remaining. We will do it on Saturday because I'll tell you why it is asking you to differentiate, why negative is there's a negative sign when differentiation occurs, and why negative sign has to be negated, right? I'll do that question. Please remind me. And also on Saturday, I would like to take up the discovery of electron, proton, and neutron. Just going to take 10 minutes, not more than that. Please, one of you just remind me. Okay. So let's just take it up, and hopefully Monday we should be able to start Schrodinger model, Schrodinger wave model. Okay. So up until that, I would appreciate each one of you to do all the questions. There are good questions in NMST for De Broglie as well as Heisenberg's uncertainty principle. Please finish them off. Now that you've understood, it's fresh, finish it off. Come on Monday, we'll start like afresh. Discovery of particles would also be done on Saturday. Na? So doubts and all, please send it to me. We'll discuss those, right? And we'll go towards if I have to do some questions on Heisenberg, that I will discuss also on Monday. At least I will introduce you to the model, halfway through the class. And then we can, in the next week, I would appreciate that this model, the wave model, is getting into your heads and, you are able to do questions. Very important model. This will help you to understand bonding. This will help you understand periodicity and whatnot. Okay. I would appreciate all of you being present in the live class. Make it convenient. Okay. Next week. Don't go anywhere. Okay. All right. Okay. Then on the count of 3 to 1, each one of you. 2 minutes. 2 minutes and 30 seconds. 3. Who has not eaten food? Everybody has eaten good food. Everybody is drinking lassi these days. On the count of 3, 2, 1. Yeah, Abhijay is also having. आज तो बहुत energy लग रही है इसमें. हाँ, सृजनी बोलो.
Ma'am, did you give any more worksheets? You were talking about
I gave
some
one
answers.
more. I don't know how many of you
Like
did
you
that.
posted the answers of the last one. The
I did that.
Uploaded only 2. I mean, you have given
No,
only 2 in the
one
book.
more I gave, yeah.
Ma'am, you actually uploaded the answers.
Okay. Oh, I must have done that in the other group then. I'm going to give you one more. One more I'll give you. Today
Thank
itself I'll give you. Okay? All right, then I'll see you on Saturday now. All right, guys. Bye-bye. Take care.
Thank you.
Thank you, ma'am.
Ma'am.
Bye, guys. Take care.